So the plan for today again is to solve some at quarter beginning problems. Да, опять без локальных тестирований. То есть будем открывать задачи и не тестируя отправлять, посмотрим, что получится. Because I want to solve B, sometime I have to practice, please guide. Just solve more problems. So if you cannot solve problems, just solve more problems. That's the only way to get better. If you have trouble solving some kind of problem, just solve more problems of the same type. That's the only way. Go. Snooki wants to play popular Japanese game. What code? Japanese accounting, but not point calculator with list from the number. Balance what numbers per pleasure with place in price and represents not exceeding as follows. Hon when the Jesus one's place is 2. Oh my god. 4, 5, 7, 9. Pawn when the Jesus one place born when the Jesus place is 3. I hate this problem so much, but why not? If it's come from the real life, why not? Или бон. 4, 5, 7, 9, 2, 4, 5, 7, 9, 0, 1, 6, 8, 0, 1, 6, 8. Okay, what's next? Let's remember K print S without change. Okay, I can do it. If an exceeds K, extract K first characters, append to end of them and print the result. Yep, that's actually a good advice. So if you think too much about algorithms, you will not be good in the contest, because in the contests algorithms are not the most important thing. The most important thing is just to solve the problems. So you need to be able to read the statement of the problem, understand what's going on, and solve this problem. That's the main thing you need to train. K and then S. If S size is no more than K, then output S, else output first K character, subsetter K and dot. Okay, now we're going yeah, I started earlier than yesterday just because I can. Maybe we'll have a longer stream since we don't have any football today. Maybe we can solve. We have too many contests to solve. So again, we are here and we need to go here. Yeah. So a lot of stuff to do. So It's better to start earlier. Still clock was or minutes and it became centimeters long. But the endpoint of our endpoint with the mean kind of fixed at the same point around. Let's make a full rotation. Lately, what is this? What? What I need to do? What is the distance between the unfixed and distance? You mean like Euclidean distance? Like this distance. Okay. I have them in doubles. So now we need to find the position. Yep. So first position will be A multiplied by sinus of what? X1. So A is hour. So hours. So the full rotation is 12 and it's 2p. So it's divided by 12 and multiplied by 2mp, right? So it's divided by 6, right? Right. I'm not sure if it's x or y. It doesn't matter actually. And y the same by cosinus. Why do you switch from Java to C++? Because all the modern contests set time limits based on their C++ solutions. And if you code in Java, you always need to take care of your solution is as optimal as possible, because the time limit is set for C++ and Java is slightly less optimal than C++. So your solution might be slightly more optimal than it should be. So you always need to write the most optimal solution you can do, because and you always need to think about it, and it's kind of stress. And when you work in C++, you don't care. You make like set of vector of pair of something. You never can do it in Java because every pair is an object, every set is an object. So if you make million of objects, Java will be extremely slow, and you can do million pairs in C++ and you cannot do million pairs in Java. That's why. I forgot what I was doing. Is it correct? Looks fine. So now we find coordinates of these two ends, and we just need to find the result. The x will be x1 minus x2, and y1 minus y2. Do they have hypod function? Oh yeah, they have hypod function. Looks fine. I know how hypod function works in Java again, and I don't know how it works. Okay, and don't forget to make set precision like this. Good enough. So it's this coordinates divided by 6 multiplied by p, because they're 20, and yes, 6 hours are equal to 1p. Yeah, so here 30 minutes equal to 1p. So b multiplied by this, b multiplied by this, find the difference, find the difference, find the distance. Yeah. ID is C line as usual. Yeah. Yeah. Ah. We lost again. Oh, I'm stupid. Sorry. So H is not the position of our handles also again. You have two hands, yes. So H and M is the current time. It's not the position of these two hands. So position of M is like this, and position of H is not H. It's H plus M divided by 60. Right? That's the correct position of the first hand. Too bad. And in the first sample is done bad because you have 0 here. Yes. Sorry. It's actually sad. It was quite a good start of the contest. Okay, we have rooms and M passages. Rooms are numbered. Not running code locally. Yes, I'm trying not to run code locally. It's just a workout, just to help my brain to write a good code without any testing. Because if I know I will be able to test, I will not try to write the best code from the first try. Ever instinct halving preference notes? No, I did not. What's this? It says computer programming book. Yeah. I didn't read it like I read this how it called, the first page of the contest. It's just, it looks like a fine book if you want to start the competitive programming. It's like not very deep explanation of the algorithms, but it's deep enough to use them in competitive programming. I don't know, if you just want to use algorithm for competitive programming, it's quite a nice book. So you will learn all the basic stuff you need to know about algorithms. But I'm not sure if it's that important. Does the cave have M rows and passages? So again, we have graph of N vertices and M edges. The room's number from that is passage connects to bidirectional. So we have unidirectional graph. One can travel between each rows, but each one has a specific room and entrance from the outside. Okay. It is dark in the cave, so we have decided to place a signpost in each room except for one. The signpost in each room will point to one of the rooms directly connected to the room with a passage. Since the dangerous cave, objects to satisfy the room except for one. If you start in that room and repeatedly move to the room indicated by some spread, you will reach the point after traversing the minimum number of passages. And where is the way? What? How it can be no way? If it's not connected. No, it is connected. So how can it be impossible? I think it's always possible. They just want to trick me. It's always possible. You just build this network of shortest path using breadth search algorithm, and it will find you all. What I need to output. Yep. For each room, I need to find the previous room in the breadth search. This will be my graph. from 1, so null there from 0, now jx push back y, jy push back x. Okay, I read my graph. That's all. Now I just run the breadth search algorithm. So this will be the array of marks. I call it Z just because of reasons. Yeah, that's alphabet. So this will be array of marks. I mark the vertex which I visit in my breadth search. This will be my queue. Why do you prefer just matrix? What matrix? What? Map from int to list. Why? You don't need maps here. Just you have an array. Why use map if you can use array for the same purpose? It just doesn't make sense. So if in your maps your keys are small integers, you use array instead. It will be faster and it's easier to use. Okay, this will make queue. I don't know how to use real queues, so I use vectors instead. So I push the first 0. True. No, array is a map, but the keys are small integers. You can think about this array as a map with just small keys. If it's easier for you. I have quite strange implementation of breadth first search. So this is breadth first search. I will iterate over queue and then read the same values for the queue. Sorry, it's not the best implementation of breadth first search, but it's good enough. And I need to remember the previous scheme. No, having maps is not that bad, but it's much slower than arrays. So if you can avoid using maps and use arrays instead, why don't do it? Arrays are easier and they are faster. Let's breadth first search. Now I need to output the result, right? I'm not using the queue because I'm not. The fact is I don't know how to use queues. I'm not good in C++. So I'm trying not to use data structures which are not that important. So I just limit my internal library with some data structures I know how to use. So I know how to use vector, so I use vector. If I can avoid to use queues and use vector instead, I will do it. Just because I'm... Again, if you just limit your elements of some small set of operators, small sets of data structures, it's just easier for me to do it. And it's not good. It's just because I'm bad in C++. Looks fine, right? Looks fine. Again, this is not a competition of the best code style. It's competition of the algorithm. So if your solution is working, it doesn't matter if it looks nice, if you use best data structures for your data structure. If your code is working, you're fine. That's what these all competitions are about. So it's competition about if your code is working or not. If it is working, use any data structure you like. If it is too slow, then okay, then you have problem. Okay, let's try to use queues. I'm actually curious, so let's try to use queue. How to use queue in this data? How to use queues in this language? So queue, I must have two operations, like push. It looks like operation that pushes something into queue. While not queue empty. Oh, I just guessed right. Queue pop. No, it's void. So how to take value from queue? Front. Top. No, there's no top. Front. Front looks nice. And now queue pop. Yep. Like this. Yes, I know how to use deck in C++, actually. Sometimes I use deck in C++. Like this. That's something I know how to use. It's the same as vector, but you can push and pop from both sides. Yeah, that should also work. Let's just try. Okay, that also works. So. No, again, that's only because I don't think that comfortable using data structures. I'm not using quite often. So I use vectors very often, so I know how to use them. I know what happens when you use vector, what may happen when you push something and then use the same link and so on. And I'm not using queues that often, so I don't know what may happen when you use queues. So I try to avoid all data structures which I don't use normally. It was D? Oh, it was D, so we have two problems left. We have called answer times. Okay, so this is the delishness and fragrantness. What is it? Wow.
Fragrantness.
Okay. Fragrantness. Okay. Why not? Use a new word every day. Fragrantness of the AI and BI respectively. We will choose one of more of these sardines and put them into a cooler. However, two sardines on patterns cannot be chosen at the same time. When terms, if only. Okay. In how many ways we can choose the set of sardines to put into the cooler? Since the count can be enormous, print model. Now again, we did the same trick yesterday. Again, how to solve problems like this. You have some strange equation, like AI multiplied by AJ plus BI multiplied by BJ equal to 0. what you want to do is to put everything connected to I in one side of this equation, everything connected to j in another side of this equation. So I will just put this to the right. Now we have ai aj equal to minus bi bj. And then I will put this aj to the right, this bi to the left. I'll have something like ai divided by bi should be equal to minus bj divided by aj. And that's what we're looking for. So if we have a situation like this, then these two sardines are on bad terms, whatever it means. Okay. So we need to find a subset such that for any two sardines we don't have a situation like this. And we don't find the maximum. We'll find it to how many ways. Okay, so we need to find the number of different subsets with this property. Okay. So what's going on? So it's basically like bipartite graph. So if you look on this property, you have some sardine I, and it is in conflict with this sardine j. If you find another sardine which is in conflict with this, like this sardine k, then actually this I and k should be equal. Means that this fraction should be same for this I and k. So this I and k will be like equal. So if you have another sardine here which is in conflict with k, it will also be in conflict with I. And that's all. So your whole world will, so all this set of sardines will be split into parts like this. So you have this one part, another part, and all sardines in this set A are in conflict with this sardines in set B. So you have these pairs of sets. So all sardines here can be put with all sardines from here. And now what you actually want to do is to find this pair of sets, and from each pair take the not maximal. We don't maximize. We don't maximize. We find the number of ways. So if we look on these two sets, we can take any subset of sardines, but only from one of this set. So we can take any subset from here. It will be 2 in power of number of elements here, plus any subset from here. It will be 2 in power of number of elements from here. So we find this pair of sets. So if we have x elements here and y elements here, then from this subset we can take 2 power of x possible subsets from here plus 2 power of y element possible subsets from here, and we counted empty subset twice, so we send -1. So that's the total possible number of subsets we can take from this pair of sets. And that's all. Now we do the same for all these pairs. From each pair we calculate this number, multiply all these numbers to get the result. That's the plan. That's the plan. Can the element be can the element be conflict with itself? So it can be negative. Can the element be in conflict with itself? Actually can. So there will be problems if this b equal to 0 or this a equal to 0. So need to be careful. Hate this. So I will count these fractions as rational fractions. So I will put these as rational fractions as nominator and denominator. Then I will divide both numerator and denominator by the greater common divisor. So I will remember each of these fractions as a normal fraction, like two numbers. And I also need this sign. And what if I have zeros? What if I have a 0 and 0? Oh, if I have 0 and 0, it means that this sardine actually hates everyone. So I always have 0 in this equation. So this is a special case. So if I have 0 and 0, I need to put all these sardines in a special group. And if I, yes, and I can take at most one sardine from this group, because they will hate all each other. Oh, okay. Okay. Let's try. Well, that's an interesting problem, actually. It's not trivial. Like this. Just for simplicity, okay. Now read the input. Let's do it like this. Let's make a vector of pairs of long and long C. Yeah. It's plus. So if A equal to 0 and B equal to 0, then special case, just calculate them. Okay, now now it is not 0 and 0. Let's calculate the greatest common divisor. Well, I never used this. There is just a G implemented in C++ somewhere. I never find how to use it actually. It's good time to start to find something. It's educational content, right? Function. Yes, I remember something like this. But it's not working. Why is it not working? My C++ is bad. I'm so bad in C++. Not my touch. It's not about touch, but it's about editor, right? How to set my C++ version? No, it's just coding. Hate this. I hate this so much. That's why I never use it. Build execution till chain. Let's it must be here. I know it must be here. 17. So it must work, right? And do they have C++ 17? Is it 17? Okay, let's try. If it's not, I will just implement GCD from scratch. It's easy function. I can implement it in like 30 seconds. Okay. If less than 0, or if pi equal to 0 and ai is less than 0, here I'm trying to convert every fraction to some canonical form. Yeah. So I want the denominator to be positive, and if the denominator is 0, I want the denominator to be positive. That's all. Now I converted every fraction to some canonical form. Push back and place back. Okay. I'm just thinking what is the easiest way to implement this. I don't do it like this. Let's. I will implement it in a simple way. I will just count how many times like this. It's not the best way to implement this. Like this. What's in place back? Is it push back? Yes, it's like push back, but it doesn't create another pair, so it's slightly faster. I don't know, if I read pushback, CLion always suggests me to change it to place back. There's no big difference. Okay. Yeah. Okay, we'll find the pair. Now let's find the opposite pair. The opposite pair will be minus q second, q first, right? And again, yes, if p sec yeah, simple is strictly better, but it's not that big advantage. So If you use pushback, it's still fine. If you want to win another millisecond, that's something you may want to do. But in our case, we don't usually think about milliseconds. We think about big stuff. Okay, so if p second less than 0 or p second equal to 0 and p first less than 0, I'm just doing the same stuff as here. Then p first equal to minus p first and p second equal to minus p second. Okay, so I find these two opposite elements again, like here. Let me show you again what's going on. So this value is q, this value is p. So I find this pair, I find this pair. And now I need to calculate the number of elements here, number of elements here. Just do the same trick. So will be sin t of q and y sin t of p. And now I simply add to result so I need power of 2 of x, power of 2 of y, minus 1. Yeah. That's fine. So the maximum is n plus 1 of 0 equal to 1. Oh, I forgot about this. Oh, I forgot about this as 0. So from this as 0, we can take any element, right? Any one element. Yes. So we can take one element from each of these and nothing else. So we need to add all these elements here. Like this, right? What is uninitialized? Thank you, C-line. Oh, you actually a good catch. Again, let's read it again. So what's going on here? We read the data, we find these pairs. For each pair, if it is 0, 0, we just put it here. If not, we find the greatest common divisor, divide by this divisor. I hope it's, just to be sure, I don't know what's going on when you put negative numbers into this GCD. I actually think it works fine if you put negative numbers here, but just to be sure, because I don't know how this works. Actually, I can Google it actually. Again, what if I put negative numbers? Yeah, it takes more than one, so I don't need this actually. Okay, so we find long is long here, yes. Again, because I moved from Java, I always have problem because I write long and expect it to be 64 bits. So at some point I just make this define and don't ever think about this problem. So again, if denominator is negative or denominator is 0 and denominator is negative, I'll just invert it and place back, calculate the number of each pair, make array of used pairs, modular, calculate powers of 2, 0. If it's already used, continue, find the opposite pair. So for this pair I find this pair, it's minus this, minus second and first. If it, again, normalize it, normalize this pair, then count the number of these elements, number of these elements, add these to result, and yes, mark both these pairs as used. Looks fine. No. We missed something. We missed something. Look on the second sample. That's sad. Okay, let's read the second sample. Maybe we didn't understand this. Oh, okay. Second sample is too big. I believe we can read it manually. So we have 3, 2, 3, 2. Can we get an empty set? Is it fine to have an empty set or not? One or more. So we cannot take the empty set. So why the first test is... it's not plus. We need to multiply it. So for each pair, we find this result, and then we need to multiply this result for each pair. My bad. Like this. And here I subtract the empty set. Yep. Okay. It was unnecessary, so... Well, I look at exactly this line and think, why I have plus here? But then I think it's fine, but okay. Final one. Since this filter is small count. The point that is x same as this point casting. And north, south lines and M. We have a picture. Oh yeah, they have a picture. I don't like this picture at all. I don't like this picture. Okay, just 1,000 maybe fine. Oh, you can see the problem. Okay. So basically you have picture like this. You have this cow and you have number of segments. And you need to calculate the total square of the area which is connected to the cow. So cow is standing here. You need to find the total area of this area. You got it. So you find out the total area which is connected to the initial position of your cow. Jim. The helper plugin. I don't like to use any extra plugins. I'm trying to keep everything simple as possible. So I have very short template. I don't have any extra plugins. Just something like this. I don't know this is the easiest way to solve this. Actually, I do know, but do they guarantee that the segments are not intersecting? Can these segments intersect or not? Yes, I think they can. Again, the simplest solution for this problem is just to build grid of these points. So I have just 1,000 of these segments. So I have 1,000 of these segments and 1,000 of these segments. So I have 2,000 of segments. So I have 4,000 points. Yeah, it's still fine. So what you can do, then let me push this. So what you can do is to build this grid. So we have the, let me show you. So you have these segments, like here. There's too many segments. Let's add one more here. And one more here. So what you can do, you have some segments. You may split your plane into regions, into like rectangle regions. Let me do some like this. So you take all possible x coordinates and you take all possible y coordinates like this. Let's have the same coordinate. And now you just split the whole plane into these regions, like this. So you have something like this. And now you have basically a grid, like you have two-dimensional array. Yeah? And in this two-dimensional array, you just need to find the connected region. So you start from the starting position. Now from here, you have your starting position of your cow, and you just mark everything that's connected to this position. So this rectangle is connected to your cow. Now you find that you don't have this wall between these two regions. So this region is also connected, this region is also connected, and that's all. And now you calculate the area of each region and then take sum of all these areas, and it will be total area connected to your cow. So that's the plan. So I will find all possible x coordinates, all possible y coordinates. Now I will build all these walls. In the end, I will run depth first search from the starting position and find all regions connected to my starting region and find the total area of these regions. That's the plan. Let's move this. Let's move it here. Here. Okay. So I have n and m. The answer is always the integer, of course, because again the area of each of this region is integer, because I have all coordinates are integer and all segments are horizontal or vertical. So everything is integer in this problem. Let's just remove it for now. Maybe get it back at some point. So I have this. Yes, I have A, B, C. What? So first I have horizontal segments. I do it like this. So I have A, B, C. A is x1. B is x2. And C is y. Now the second process is n plus m. Now I read D, E, F. D is x1, E is y1, and F is y2, and x2 equals to x1. Okay, now we read the input. Now let's put all possible x's into and all possible y's into this So this will be arrays which contains all possible coordinates. Nice. I'll just sort this array. And erase everything else. Yeah. And do the same for the y's. Yes, I can extract the method for this, but I will not do it because I'm lazy. That's all. Now we find all unique x coordinates, all unique y coordinates. Now we need to draw all these segments, actually. Yes, we need to draw all possible segments. How to draw the segments? Okay. You can do it. I can do it a simple way. So I will put all vertical segments in one array, in one two-dimensional array of booleans. I will say if there is a wall between these two cells. So I will have an array of booleans, which for each of these vertical segments will say if I have wall between these two cells. So I will put these vertical segments in one boolean array, and in another boolean array I will put all horizontal segments. That's the plan. That's the plan. Vector. Let's say an x will be x size and y will be y size. So vertical segments, the size of the vertical segments will be x and y. Okay, let's have x and y. So by x, I will have an x plus 1 possible positions. And by y coordinate, I have n y possible positions. So these are all vertical segments. Just to keep them of the same length. I have an x and an y plus 1. So I will put all vertical segments here, all horizontal segments here. Nice. That's all. Let's fill this array. So we iterate all. So here I have the horizontal segments. For horizontal segments, go watch Dota. What's happening? Is it the tournament or something? What's going on? What's going on?
Taking the series 2-0. Wow, what?
OG versus synonyms. Okay, I'll finish this problem and we'll go watch some Dota. Let me finish this. That's only the first contest. Yeah. I didn't even finish. No, it's the second contest, right? Is it the first contest of today? Yep. Yeah, it's only the first contest of the day. So it's... Let's go. So what we need to do, we need to fill this array. Let's go fill this array. Yeah, so for horizontal segment I need to find the position. So I need to find this y equal to in the y begin, y end, y1. Okay, so I find my y coordinate. Now I will let's do it like this, just because I'm lazy. Not the best way to do it. Okay, I know I can introduce the method here, but I will not do it because I'm lazy. Nice, it's good code. And now I just go from x1 less than x2 and segments t y y. Right? Let's see, why have +1 here? I don't need +1 here. Yeah, I don't need +1 here. Actually, we have -1 here, because if I have n points, I have n minus 1 segments. Yeah. And now we do the same with vertical segments. Yes, you never do it like this. That's the worst way to write the code. Very bad code style, very bad. So xx is the number of this x in the list of all possible x's. So I have all possible coordinates here, and I will change them with numbers like 0, 1, 2, 3, 4, 5, 6, 7, so on. So instead of having the coordinates, I will have these indexes in this array. So this x is the index in this array of all possible x's. Just here I put all possible x coordinates in this array, sort, erase duplicates, and now I can do it like this. Looks fine. No, horizontal first. Okay, so now I draw all these lines, and now I will just call it depth first search. No slide of any given segments. Okay. I need to find the segment which contains 0.00. 0.00, so I need to find this line. This line is actually it is it doesn't matter. So if it is, so if one of these lines goes through 0.0, it doesn't matter, right? The lower bound will give me the next element, right? If I don't have 0, it will give me lower bound gives you the first element greater or equal, right? And I need element less than 0, so it's -1, right? So that is starting position. It's starting position of this 0.00. Now from this position, I need to run a DFS. I'll make them global. Yep. Just to make it simple. And I need to make array to mark the cells I visited them. Yeah, I call it Z just because. Okay. Okay, let's go. So if I'm outside of the border, if s is less than 0 or x is less greater than z size equal, or int, or if y is less than 0, or if y is greater than x size, then I'm outside of the border. If I'm outside of the border, it means the answer is infinite, yes. Now, if it's already marked, I return. Now it's simple depth first search. And now I need to go in all 4 directions. So if I can go to the left, I can go to the left if for x, y, if vert x, y. If I don't have this wall to the left, I can go to x minus 1 and y. I'll simply do it 4. Again, it's Doesn't need to write the best code every time. It's just the code which solves your problem. It's not the code beauty competition. Okay, it's +1. That's all. That's nice data search actually. Again, so if we are outside of the border, we say the answer is infinite and return. If we already visited this cell, we return. Now we mark this cell as visited and look on the borders. If we don't have border to the left, we go to the left. Now we go to the right. Here we go up. Here we go down. That's the first search. Now simply calculate the result. If inf, then we output what we need to output inf. Okay. If not, let's calculate the result. So if we visited this cell, we add to the result the total area of this cell. Total area of this cell is, of course, xi plus 1 minus xi multiplied by yj plus 1 minus j. And I will not give integer overflow in this point. Whew. What? What's the problem here? Narrowing conversion from long to signed up it is implementation default. What? Because of this -1? I don't believe this code will work from the first try. Oh! That's unexpected. Okay. Okay, easy. Easy. Okay, let's have one more. Is anybody here? What's going on here? Yes, we have 30 viewers. You want to start from another part? Oh, okay, we can move in any direction. Let's. This is kind of scary. Let's go. Let's try to first to solve this. So this is the last beginner contest, right? Actually, the new beginner contest will be tomorrow, so I highly recommend to solve it, and then we can discuss it in some future streams. Ah, okay. So that's the last beginner contest. Okay, let's try to solve it. Is it possible to get some of the truant and die with 6 faces 8 times? So how to say if it's possible or not? So B should be at most the minimal numbers. The minimal number of we can get is A. Yeah? And B should be no more than maximal number of we can get. Maximal number is 6A. So any number between A and 6A can be obtained by this sum. Yeah. Okay, nice start. The coins is going to take 1 factorial, 2 factorial, and 10 factorial. Okay. Guess has 100 of every of the coin, and he's going to buy a product of P, and by given the exact amount of receiving exchange. We can prove that there's always such a way to make a payment. At least how many coins does he need to use in his payment? Okay. So when each number is a divisor of the next number, you can do it. You can, yes. When each next number is divisor of the next number in the sequence, you can do it greedily. You can do it greedily. So I will just say this P, load this number P. Make everything long just for simplicity. Now I will calculate these factorials. 10 factorials, okay. From 1 to 10. Well, why not? So F0 will be 1, 14, 1, 10 plus plus Fi will be Fi minus 1 multiplied I plus 1. So it will be 1 factorial, 2 factorial, and so on. That's all. Now let's go long res equal to 0, 14, 10, 9, 0 plus. Now I'll do it just in this way. I'll make it like this. Okay, okay, I will not do it like this. So the number of coins of this type is P divided by factorial. Right. Now we add this number of T, we subtract it from P. So here I calculate all these factorials, and now I simply greedily use the maximal possible coin. You can do it when then the values of your coins are divisors of the next one. So if each value is divisor of the next value, you can do it greedily. So I can start from the maximal coin. 10 factorial fits in integer. I don't want to think about it. No, you can calculate on a calculator and see that 10 factorial actually fits in 32 bits integer. I'm quite sure it will fit in 64 bits. I'm not sure about 32. It will fit in 32. Okay, it will fit in 32 bits. I don't want to think about it, so I just use 64 bits just to be sure that everything will work. Test? No, I will not test anything. Testing is for the week. I will upload it to YouTube. Yes, I uploaded my last stream on YouTube, and I will upload this stream on YouTube. Yeah. There are n citizens in Kingdom of Takashi. Each citizen has a national ID number. The ID of citizens AI. Here's AI. Prior is different. Okay. So each citizen has some ID. Okay. Takashi has piece for speech. He had decided to hand out these pieces citizen in the following way and deal with 1 pieces. And he has n or more pieces. Hand out 1 piece to every citizen. Okay. Otherwise, let key prime be the number of pieces at the moment. Smallest IDs. So what's the problem is about nothing. So k is big. Okay. Title to the video title. I usually write multiple contests in these streams. Maybe I need to add it to the contest, to the video title. Yes, maybe you're right. Yes, maybe. Usually it's like 2 or 3 contests per stream, so it should be fine. Yeah. Okay, I read N, I read K. Now I need to read this. Okay. Now I need to sort this by integers, but don't forget. I will do it just like this. That's the simplest way to do it. Like this. No, I mean testing is for the weekend. I mean that. Okay. Being able to test your program and find the bugs in your program is an important skill, but I'm trying to train another skill. I'm trying to train a skill to write a code from the first try. It's another good skill to have when you write a contest. So when I write the code, I'm trying to think about how to write it to make sure it will work without any future testing. Because in ICPC style contests, you will have some tests, and you can make multiple tries. So you send your code, you get the result. If you have wrong answer, you can find the bug and send it again. In some other contests, like in top coder contests, you don't have this possibility. So you send your code, and then in the end you will have a result if your code is correct or not. If it is not correct, you can't resubmit it. So for contests like this, it's good thing to train is to write the code without any bugs from the first try. Something like that. I'm just trying to train my brain to do it from the first try. What else talking about? So we have a very simple problem actually. So first, let's take all policy and add them k over n elements. Now we split all these elements, and now k equal to k. So now we have all these remaining elements, and we will add this element to the first k people. So first, okay, we'll look into this array B and take the element bi second. It's the index of these minimal elements. Okay, I put these elements here, sorted. So second element is the index of this element. So I take the index of these minimal elements and make them plus plus. this. Okay, first problems are not that interesting. I see this sum and I start to hate these problems right now. Okay, let's read. Oh, and cities and cities, emeralds. Okay, cities are numbered, right? And rows numbers. One way road from Lisbon city. Okay, we have a direct graph. And it takes, we have weighted direct graph. Let's define f. I hate when you formulate problem like this. Okay. Compute the minimal time needed to get from S to T. Okay. Here, other than the cities S and T, is only allowed to pass through cities A through K. If city T is unreachable, or S equal to T, the answer should be 0. So it's just the thing which you calculate in your Floyd algorithm, right? Compute f SDX for all triplets and print the sum of them. So just implement the Floyd algorithm. What's going on here? Okay, I believe this is exactly what you calculate in the Floyd algorithm. So in Floyd algorithm, you calculate the minimal distance between S and T when you can only use cities from IQK. It's a very strange problem. So I don't have parallel edges, I don't have loops. All distances are 6, so distances all fit in 32-bit integers. Let's put zeros like here. Yeah. Here we have zeros. Let's do it like here. Probably must call it Floyd sum. Oh no, it's not cool. it would be cool to call it Floyd sum. Yep. For all triplets k, so k from 1 to n. From 1, not from 0. Okay, so I go from to n. So it shifted, so okay. So now I can use all vertices from 0 to k inclusive, right? So I do it like this. Don't like these zeros. I put infinities here. Yeah, this will make life a little bit easier. Yeah, now I make it simpler. I put zeros on there just in case. I'm not sure if it is important or not. I just love to have zeros on the diagonal of the distance. There's just there's more for the aesthetic reasons. Okay, now I calculated the step of the Floyd algorithm, and now I need to calculate the result. Yeah? And if s equal to t, answer should be 0. Okay. I think it's nice code. Yes, we have 4 problems in a row. Oh, 4 problems solved, 2 problems left. Oh, I don't have. I hate when I have such small solutions, some short statements. Usually it's something very painful. Usually it's something very painful when we have small statement. For how many positive integers at most n is the product of the digits at most k? Product of the digits is at most k. Okay, let's see. I hate this problem. Okay, so we need to find the numbers such that the digits are small. Is there many possible products here? because we only consider numbers of, so they can only be divisible by 2, 3, 5, and 7, right? Because we only have digits like this, so not all these numbers can be actually I'm just thinking, can I have a dynamic programming over all possible values of this product? Because if you like go from right to left and remember the current value of this product, is it fine or not? Or you may think about not the product but the remainder of this person. So if you divide this maximum k by the current product, you will get some number which is this k divided by something, and there will be no more than square root of k possible values here. Yeah, so I think it's a nice plan. So I'm thinking about dynamic programming. So I will construct this number digit by digit. And each time I add new digit, I will update this limit on the total product. Just by devise. If I have 0, is it fine to have 0? Product of digits. So if I have 0, the product is 0. So any number containing 0 is fine. The dynamic program of, I think it will be too much. So if you do it like this, let's think. Let's think. Let's think. So if you do it like this, let's think of that power of 2. Power of 2 maybe up to maybe up to like 30, right? So we have like 30 here. Power of 3. Or maybe it's fine. Yeah, maybe it's fine. Well, because this number is a composition of digits, and you have only decimal digits. They have only these primes in the. Yeah, it should be fine. Yeah, I agree. I'm just thinking about how to implement it easily, because we have this constraint n, and we need to take care about this n. No, let's just iterate for all possibles. Sorry, I'm just thinking, so that's fine. Now let's do it like this. Let's put it to string. So I want to take the length of this number, so it's from 1 to I'll show you in a second. I'll show you in a second. Like this. So I want to fix the length of my number. So I want to calculate all the numbers. Okay. I want to calculate all the numbers of this length less or equal than my number, because the length of the number is different, number of digits. So here I will only calculate the numbers of the same length, and here I will calculate all the shorter numbers. That's the plan. Just like this. No, okay, it's fine. I will just copy it from you. So I will just believe that your calculations are correct, okay? Is it the same here and here? Looks strange. Put it here. So this will be the length, and this will be 10 power 18 is actually 19 digits, so it must be 20. Hate you. Yes, and I need two arrays, because I need to remember if the current element is less or equal. Okay, I don't need this. Oh. Yeah, okay, let's go. So we take new digits. If it is not multiplied by 0. We will also have these zeros. I hate zeros. Zeros. What to do with all these zeros? Can I just do it like this? Let's just like this. So what I'm doing here, for each product, I will calculate number of ways to get this product. So now I have this digit. I will take all digits. That's the plan. Plan is like this. Make a dynamic programming for each possible product, calculate number of ways to get this product. So now I take my digit. My digit may be from 0 to n to 10. So if I equal to 0 and x equal to 0, then sorry, I can do it. Now, if yeah, now I can iterate for all possible variants of RAD and see if p first multiplied by x is less or equal than k, then it's fine. I can put this digit here and now my product will be multiplied by x. I do it like just to be sure, because I will multiply this by 9 and get integer overflow plus equal dp second. Right? So I put this digit here and I have this product. So the result for this product should be increased by the number of ways. And now I need to look here. So I want my number to be less than this number. Less. Let's make it strictly less. So if my digit is less than C, then I can put the same prefix plus this digit. Yes. So if I take the prefix, multiply it by x, and it will be less or equal than k, then I can take the whole prefix plus this digit, and I have some prefix which is less than the prefix of I need. Yeah. Plus plus. Yeah. Like this. And now I get rid of all these special cases. Now in the end I need to check if PS is no more than k, then I can make the whole string like make equal to n. Yeah. So I will increase the result by 1. Yeah, I need to yes, I need to calculate result. It's C++, you can do it like. So in the end you just like this. Yeah, I think it should work. So again, in this dynamic programming I calculate the number of ways to get the prefix with this product. So this value is the product. Number of ways to get this product on this prefix such that this prefix is less than my prefix. So this prefix should be less than prefix of string s. Strictly less. So if my prefix is strictly less, I can add one more digit to this prefix, any digit, as long as this product is less than k. So I add this x to my prefix, get this product, increase this value. Or I can take the prefix of string s plus this character x if x is less than c. If it is less than c, I take the prefix of string s plus this character x and have this prefix sum plus multiplied by x if it is less than, so I do this plus plus. So in the end I update my prefix sum and change the map of this map. Here I calculate the result, so I just simply add everything for all possible products. And if total product is less than k, I can take just the string s as a result. So here I calculate everything less than s, and here I calculate string s if string s fits into the result. Looks fine. Here what I'm doing, I calculate string of I characters equal to 9, and then call this calc function. This calc function will calculate everything of the same length as string s. So I will calculate all possible numbers of 1, 2, 3, and so on digits. And here I will calculate everything. Let's just try. I'm a little bit scared to send this without any testing. Will possibility limit? That's a good question. I think there is not so many possible values of this product. So I think the number of possible values of this and of this keys is pretty small. So the size of this map is always small, so it will be fine. That's my guess. There's only one way to find out. I forgot to print the answer. That's the dumbest way to lose the contest. If it is the only bug, I will be so sad. No, it's not the only bug. So it even works on samples, not on the second sample. But it's not time limit, so we just have some bug, right? Let's work on this sample. We may have some integer overflow at some point, right? Like here we may have some integer overflow, right? Oh no, PS is already long, so it doesn't matter. But here I kind of scared that this is int, and so because it's less than k and k is integer, so it should be fine. So this number is small because this number is small, and this number is small because this number is small. Yeah, looks fine. Use alone to be safe. Since I'm not sure what time complexity I need in this algorithm. Looks fine. So what made the problem? So again, I take the digit of my string. Iterator all possible digits I can put in my string. I cannot put 0 on the first position. Now iterator all possible states. If I can add this digit to my state, so I add this digit. It works totally fine. Yes, initially this map is empty just because I want prefixes strictly less than the prefixes of string s, and for zero length prefix it's not strictly less, it's exactly the same. So for example, here is empty. I cannot make prefix less than empty prefix. Here, if x is less than c, then I can make a new prefix less than prefix of string s by taking the prefix of string s plus this character's x. If this prefix multiplied by x. Here, can I have integer flow here? If I have, no, I might have like 18 nines, yes. So it's up to 18, so I have 18 nines. It still fits into 64 bits. Can you spot the problem? I cannot see the problem. No, I don't see the problem. So here it's not working. for this sample is not working. It looks fine. What made the problem? Here just add p-second. Just add. Right. Yes. Well, let's check for possible integer of overflows where I make any computations. Here it's not here. Here I make this so I don't have integer overflow here. Here I don't have an issue because I don't have an issue here. Here I don't have an integer overflow so PS is long. PS cannot overflow. Yes, PS will not overflow. PS multiplied by X may overflow. May have long overflow here. May it be bigger than 64 bits. I think it's not. No. No, it should fit into 64 bits. X. If the next digit is 0, the prefix can be larger than K. That's a good point. That's a good point. Yes. Yes, you're right. So if it is greater than K, we'll put it in some special cell. So K plus 1 is special cell for everything greater than X, greater than K. Yes, you're right. So when we multiply this K plus 1 by X, you will have number less than K. So when you multiply something, it's not always increasing. Yeah, yes. Nice catch. Okay, so what's here? So if P first is less than equal to like this. Yep. That was better. Yep, that was cool bug. That was a cool bug. Of course, you can find this bug by testing on the samples. But who needs samples when you can analyze your code by just looking? Okay. Again, you have some functions, some modules, hate problems like this. Let's see. For non-negative integers n and m, let us define the function f and m. Okay, non-negative, using a positive integer k. Okay, f will be 0 if n equal to 0. Makes sense. Now, if m equal to 0, then f is just n power k. Okay. And if not, then it is the sum of fn minus 1m and fn m minus 1. And here n is big and m is small. So I like everything except this. This looks scary. Okay, let's put some paper and think about it. Let's think. So what do we have? So here will be n, here will be m. So zeros, if n equal to 0, we have zeros. If m equal to 0, we have n power k. So here we have 1 power k, 2 power k, 3 power k, 4k, and so on. Okay. And every number here is sum of these two numbers. So we take these two numbers, take the sum of these two numbers. And we need to find number here. Oh, there's a table. Okay. So that's how this table looks. Okay, I need to find this number. So I think the key element is this m is small. So the width of this table is very small. That's interesting. So the only problem with these numbers actually. So if you just have a situation like this, you can make a linear transformation from this string to this string, and use this linear transformation just to put this matrix of linear transformation into power of number of rows, and you will have the transformation from here to here as a matrix. But since you have a new element in each row, so how to get these elements? These elements can be obtained as linear transformation, unfortunately. Okay, let's think from the others. Okay, so each of these elements will add something to this result, and this result will be these elements multiplied by some binomial coefficient. Yeah. So if you look, for example, this 2 power of k, so it will be added to this element, and from here it will be added here, 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 and in the end it will be added to this result. So this 2 power of k will be multiplied by the number of ways to get from here to here. So so what we need to calculate is number like this. So in position I, you have I power k multiplied by binomial coefficient from something like m plus n minus I to m. Something like that, plus or minus 1. We need to calculate sum like this. No idea. Trying to find any combinatorial meaning for this. The problem is this n is big. Yes, n is big. You cannot just build this table. You cannot just build this table because it's too big. So we need somehow to do it fast. Can I increase brightness? Like this. Matrix expo. Which matrix? You can build matrix which transforms one string to the next string, but you can take this first element. This first element is new every time. It will be nice if you can find this a power of k as a matrix transformation, but actually I think you cannot. So you can do it, but the size of the matrix will be up to k, and k is big. Yeah, k is big. It's interesting. It's actually big, but not that big. We can iterate up to. Let's see. That's actually strange. 2 power of 2.5 vectors. It's very strange constraint actually. I'm trying to find some combinatorial meaning for this formula, but I'm not sure if it's possible. Okay, I have no idea what to do. Let me have some more tea. Any guesses? Can you solve this if there is no binomial coefficient in formula? You just take sum of these powers. You can calculate it just in formula. Yeah, Fallhaber formula. Yeah, I give it my background fast enough from the computer. Yes, without these coefficients, it will be just simple formula. That's interesting. That's interesting. What else can we do in this problem? We still didn't use that the m is small. This m is small. Yeah, no, I can calculate these things as some linear stuff if I don't have the size of this equal to k. What? Because sin m is small, because a small amount of what? Choose b minus. Since I don't get it. Ah. So what? No. Yes, the width is small, so you go to the left small number of times, but the height is too big, so you cannot just calculate it. You need to find some formula to calculate this thing. I don't like these powers at all. What's happening with these elements? Is there another way to think about these numbers? So it's some polynomial, yes. So if you look on the if you look on the next on the second column, so each number here is the as this name suggests, is the cumulative sum of this. So the sum of the prefix of the polynomials is another polynomial, right? Just need to think what polynomial. I'm just afraid it may be too big to calculate. So in the first column you have polynomial, you see, n, m, m, n power k. So what happens in the next column? In the next column you have a sum. You have a sum of n of let's say I power k for all I from 1 to n. So these sums are something. So how to calculate this sum? No, not this. Yes, thank you. Is it a formula for? So I have these binomial coefficients here. No, I don't get it. If I just calculate it's too complicated. I can't apply it every time. So what I want to do is to find the polynomial for the first column, then starting from it, calculate the polynomial for the second column, and so on. But I can just apply this formula. Maybe I can somehow calculate just this polynomial. So if I have this polynomial, try interpolation. Unfortunately, it's too big. The size of the polynomial is so this power is too big. I can't interpolate polynomials like this. But too bad. It is too big. No, I need some. I need. So if you want to interpolate your polynomial, you need to spend like a square time at least. No, this power is not too big by itself, but when you want to interpolate something, you cannot do it in linear time, I believe. Can you? I don't know how to make interpolation of polynomial faster than just solve the number of equations. I don't like this. It's actually clear how to calculate cumulative sum of the polynomial. Use this formula for each element and then calculate the sum. Oh, that's interesting. This is free, and so on. That's exactly what's going on in our problem. In our problem, we have this first sequence, and then each time we have, but we start from another sequence. We start from sequence of I power k. No, it can. There are formula for coefficient per k. This formula but that's again, this is not what we are trying to find in this problem. Okay, there is a formula for this. I got it. But, so coefficients of this polynomial are some binomial coefficients. Some binomial coefficients. Okay. How the expression for Lagrangian relation look like when applied to mod n? It actually hurts a lot. I have no idea what you're talking about. I have no idea. Nice problem. From two different beginners? Yes, I think it is. Maybe we missed something obvious. Maybe we just missed something very obvious. Go back here. Oh, I really hate combinatorics. I really hate combinatorics. And all this stuff with polynomials. No idea. No idea. No, I can do it, but it will work in k-square. K-square is too much. K is to millions. K-square will be too much. Yes, it is a beginner contest. Let's look on the standings. So how many people did actually solve it? So lots of people solve it. So we missed something obvious. As we solved it in 8 minutes. 8 minutes. Lagrange can be done in linear time, consider formula of like. I have no idea what you're talking about. I learned linear algebra like 20 years ago. I don't remember anything about algebra. So maybe it's something obvious for anyone who know how this polynomial stuff works. Yes, maybe it's some well-known problem, so we can just copy the algorithm from something, but maybe not. So there are like a lot of people solving this problem. Like 43 people solved this problem. And most of them do it pretty quickly. It's mostly people from Japan, but maybe it's some well-known Japan problem. Who knows? Google Lagrange. Okay. I know at some point we will try something like this. Okay. Lagrange interpolation for dummies. That's the next point. Okay. Yes, no. Lagrange polynomial is when you know the values of your polynomial at some point, and you want to construct a polynomial. Yeah, and there is a special form of this. Yes, like this. Yeah, you do the stuff. But what next? No, I know the concept. Like if you know the values of the polynomial in some points, you can construct a polynomial. And if you pick the points correctly, you can do it pretty fast, right? But how to apply it to this problem? So I think I can do it in linear time. How can I do it in linear time? Now, if we accept that the values here are polynomials, and values here are polynomials, so I can go from here to here, just calculating this first. I actually need to interpolate only once, right? So I can calculate this top section of this table and take this part, and from this part interpolate the polynomial. I need only polynomial for the last row, right? So I can just calculate this part of the table in brute force, take this last column, and interpolate polynomial from here. But how to interpolate polynomial? Fast. Degree. There will be some Fourier transformation, right? No? Yep. I don't want to use any Fourier transformation really. Again, I know the values of the polynomial in consecutive endpoints. Maybe it's better. So if I know position in n consecutive points. No? No, I think I still need n squared time. Ah. Oh, you know how I hate mathematics. Okay. Take the most basic formula. Very basic. Okay. Okay. Let's replace x minus xm divided by xj minus xm. J minus m. X minus m divided by j minus m. Let's do it. Okay. I'm a certified mathematician, actually. Okay. Okay. So we need product x minus m divided by j minus m for all m from 0 to k except j. Is it something interesting? Doesn't look interesting. That's educational function of this stream. Sometimes you need to learn some strange stuff. Open number stuff because I don't know how to put multiplication. Okay. F is we can calculate f6 now. Yes. What is bar expansion? Okay. x. We calculate where f is unique to the polynomial. We shall find polynomials defined. Yes, we learned in school. Okay. This is the divisor. Oh, school was so long time ago. We can write this down. Okay. Yes. Now, this question. Yes, we have the same formula here. Okay. Optimization. Let's optimize. Assume we're given f. How can we click quickly? Notice x, y, and s is fy. Substitute. Yes, we just did. Yes, we just did this. Oh, yes, this is our formula. It's product of fractions, so we can make product of nominators and product of denominators. Makes sense? We can pre-calculate suffix and suffix product of x. Then we can calculate the denominator for each I. What? What's going on here? So we need to calculate this product. Yes, we need to multiply. We need to multiply everything except one. We don't need to reconstruct the polynomial. We need only to find the value of this polynomial in one point. So I know the value of x. X is not a variable. Okay, I got it. let's go back to the problem. So what's the problem again? I will build this table, build this final row, and then for the last row, I know the values of the polynomial. I need to calculate the value of this polynomial in some another point. So what I will do, I will file this value in linear time. Okay, that's something new I learned today. So I have polynomial of no, the power of the polynomial will be not k, right? So if I start with polynomial, who needs this code? It's not the code. So if I start with polynomial of power k, next will be k plus 1. It'll be k plus m, right? So I need to have polynomial of n plus m. Yep. So I will build minimum of n and p. I will build this many lines. Yep. Yeah, starting from 0. Okay, this is the first. Now I just do it m times. That's all. Now I have the final column of the matrix. Yes. Okay. And now we simply reconstruct the polynomial. Now we know the values of the polynomial. This we need to find mean of n and p. We actually can always have p. That's also fine. Yeah, let's use p instead. We can always construct p values. If n is less than p, okay, it's not a problem. So p is the power of a polynomial. Okay, we don't need this. Yep. And now we know the values from 0 to p. And we need to find the value of the polynomial in point n. And now we use this stuff. Let's find it again. Oh, find again. So again, we calculate this denominator, calculate this denominator, and find it. Yep. Whew. Why do you need this? Why do you use factorials here? You can do it in the same. Ah, it's different. So why it's different? Ah, it's different because you have I here. Powers k plus m, because in the first column we have powers k. In each next column the power of the polynomial will be increased. Because each time you take the cumulative sum of the previous column, when you have sums, again, if you have squares, and you have sum of squares will grow as a cube. Yeah. So each time when you take sum of the polynomials, the power will be increased by 1. And since we moved m times, in the last row the power will be k plus m. Yeah, makes sense. Let's just use this formula. It's too long. This string is too long. Let's just use this formula. I have no idea what I'm doing here. So first we calculate this stuff. Let's call it q for no particular reason. K plus 1. Maybe plus 1. No? No. Good enough. So the maximal power in my polynomial is p minus 1. So I have p coefficients of my polynomial. Now I calculate this stuff. Now the plan is calculate this stuff. So to calculate this stuff, I take these numbers, and take the prefix sum and suffix sum, and then multiply them. X is the value in the position when we need to calculate the polynomial. We need to calculate the polynomial in position n. So it will be n minus I don't know. I have from 0 to n. My positions are from 0, so it will be n minus I. Yeah. Now we calculate prefix sums and suffix sums. So prefix sums will take the product of everything except this. What's that block? I know some clever guy who knows how to do math. Let's give him some respect. And suffixes. Okay, now we know how to calculate the well, I need to divide. Will I be able to divide? Yes, I hope I'll be able to divide. So f of I here. See, f of I is just the value of this AI multiplied by something. So nominator will be PSI multiplied by SSI. The denominator we need to calculate somehow. we'll do it soon. So we need to multiply AI by nominator. Take it modulo. Then multiply by inverse of denominator. And then take it modulo. Yeah. Okay, that's the plan. Inverse is simple. Okay, that's the final part. We need to find the denominator. Find the denominator, you do it like this. I don't like this. As in here, they start from 1 and I need to start from 0. So it will be slightly different. Okay, let's do it. So we need to calculate the factorials. Okay, it's fine. So the denominator, so it's slightly different from this because I have from 0 to I. So I have this I. So I have factorials to the left. So I have this. So I have I factorial, right? These are factorials to the left. And I need factorials to the right. Why is I minus 1? Because powers, okay. I think it's something like this. Why is power n minus 1? It's n minus 1, okay. So all left factorials and right factorials are negative. And I have values from 1 to n minus I. not and p minus I, yes, p minus I, okay. And if p minus I is odd, then I need to say like this, right? Okay, there's no miracle. It is wrong as expected. Your last point is p minus 1, right? Right, my last point is p minus 1. Here. Here. Makes sense. No. I'm not ready to solve the problem without this, so let's go. We already lost this contest, so let's try to do 35. Oh, it's actually working. Ah, no, in this case it's simple. Yeah. Ah, yeah. In this case, I just calculated all the results. I just calculated this, so you can look about here. But it's fine. It's fine that it's already it's actually working. So if you look on this array A, yep, carries all these values. So I might take just 35 from here. Maybe we have a wrong degree of the polynomial. It actually may be the problem. What? Yep. It's just overflow. Okay, so today we learned a lot of interesting stuff. That's nice. That's why I'm having this streams actually. Yes, this is exactly this. So they expect in the basic contest people to know how to make this Lagrange interpolation. Okay, Okay. So that's actually what what they're trying to get. Oh, but they have very short code. That's interesting. So I have like 80 lines of code and they have like 40. So it's like twice smaller than mine. It's in Python, but still, it's interesting. That's actually fine. So here, instead of calculating inverse value of this denominator, because denominator is just product of these factorials, you can calculate inverse factorials. Yeah, and then just calculate, instead of multiplying by inverse of this product, you just multiply by 2 inverse factorials. That's funny. And how do you calculate inverse factorials? Just by going from right to left. Yeah. Yeah, you can do it like this. So you can calculate the factorials, then take the last factorial, inverse it, and then go from right to left, calculate inverse factorials. Instead of dividing, you need to multiply the inverse factorial by the next number. I have no idea why did they choose this problem as a nice problem for AtCoder beginner round. But that was fun. That was fun. I learned a lot of new stuff today. Very productive day. Nice. So we spent like 3.5 hours. Okay. So we spent like, how much time do we spend on this single problem? So on this single problem we spent so from here, yes, like slightly more than an hour on a single problem. Cool. Whew. Some update. Okay, it was fun. It was fun. Okay, I think it's enough for today. So see you next time. Maybe tomorrow. No, not tomorrow. Today's Friday. No, not tomorrow. Maybe on Sunday. Maybe tomorrow morning. I don't know. So